So I'm going to do a brief introduction to Dr. Hrant Gharbiyan. And how do you do with that? No.
Last name?
Yes.
Pretty good. Yeah.
Okay, good. So I'll stick with that. Happy to have him today. It's with BlueQubit, a California-based startup specializing in crafting GPU-accelerated quantum infrastructure and QC platform tailored for hybrid classical quantum algorithms. As its co-founder and CEO, Hrant plays a pivotal role in guiding its scientific innovations and fostering strategic partnerships. Hrant is a Stanford-trained quantum scientist with a decade of experience in quantum physics and algorithms as a Simons Fellow at Caltech and a researcher at Google's quantum AI team. Welcome, Hrant. Thank you so much.
Thank you. Thank you for the introduction, and thanks everybody for coming. The title of my talk, let's see, here we go, is a specific use case for quantum algorithm development. It's a use case in insurance industry, but also can translate to financial industry and investment. But the first part of the talk, I'll talk specifically about the platform our team has developed that allows to discover quantum algorithms, benchmark them at large scale, leveraging fully GPUs and CPUs available in the market. So let's start with the platform. So anybody in the audience, if you know how to code quantum, specifically know how to run Qiskit or Cirq, you can go ahead to app.bluequbit.io and run your experiments. This will enable large-scale quantum simulations. So in fact, we're hosting the fastest QPU simulators that require zero setup from the user perspective. We have some QPUs available in the platform as well. And in the coming months, we'll have zero setup tensor network simulators and some infrastructure for specifically quantum machine learning models that will allow users to train large models with many parameters and large qubit numbers. And then I'll get into details, what the numbers are, and if you're a quantum algorithms engineer, you can email me or reach out to our team or stop at the booth and get to use the platform yourself. So as I said, here's a slide with couple benchmarks for running 32 by 32 quantum circuit. So as I said, we support Qiskit and Cirq currently. We're in the process of integrating PennyLane, which is also like very popular quantum library for QML applications. Our current simulator that we're hosting, the GPU one, with a zero setup with only 3 lines of additional code to your original circuit code, you can achieve 100x speed up on 30+ qubit simulations. This actually translates to 10x savings in cost, in a compute cost, if you use other available simulators in the market. And then simulators without any direct engagement with us, without any conversation, you can run up to 36 qubit simulations in the platform currently. And then we also have built a UI to make it easy to show the jobs that have been submitted, track them, and then also see different state vector representations that gives an intuition for users of how quantum state is stored and how operations are performed. So our platform is based on a lot of the open source libraries that giants like NVIDIA and Google have developed, such as QSIM of Cirq team, as well as NVIDIA's QQuantum library, which has amazing tools for doing quantum on a GPU. So another important things coming up is tensor network and hybrid compute methods. Those are not available right now, but will be added soon to the platform. In addition, we currently have access to Rigetti device, and we're in the process of adding IBM and QEra quantum computers. We work closely with Q-Control, so I think once we add the IBM device, so you can immediately, with one line of change, you can submit the job to actual quantum hardware. And Q-Control has been building amazing control techniques to improve the fidelities. So if we end up adding, we will try to have the best possible fidelities using error mitigation methods. Okay, now I'm gonna switch gears and talk about the case study we have done for insurance risk modeling. This was a work done in collaboration with Guidewire, which is the largest insurtech company in the US. They have a big data science team, and they work closely with insurance firms, with actuaries and data science players. So we work with our team members to build a very simple insurance use case that would be educational for insurance community, how quantum will disrupt their field in the future. Obviously, this is a much more of an R&D work, exploratory, but it was a simple model enough to be able to do a quantum simulation of, but interesting enough from a perspective of generalizability in the insurance use case. This is a problem pretty relevant for capital reserve question, which a lot of large financial institutions face. Essentially, the risk associated with allocating capital, specifically in insurance, of homeowners insurance scenario modeling, or you model different variables in the problem, like the monthly payment customer pays as a constant. T is the time to an accident, which could be modeled as exponential distribution, but not necessarily. And then X and Y are a payout and the damage probability, of, like damaged house, number of the damaged houses given certain time window. And if you're able to model this as truncated distributions, then you can try to understand if there's anything you can do with quantum computers to do risk estimation for insurance firms. So we have developed quantum machine learning techniques to load classical distribution data into a quantum state. So this is an example how our data loader works. It's extremely shallow quantum circuits that uses very similar ideas as machine learning for classical machine learning, that learning from data and computing derivatives, you try to approximate as closely as you can. And leveraging our GPU infrastructure, we're able to train up to 30-qubit quantum circuits with 1,000 parameters and load all kinds of distributions, some known like normal distribution that's analytically known, some like distributions that come from nature or like observed in a realistic data set. So after we load the distributions into the quantum device, then we need to perform operations on the distributions like adding and multiplying. And this is done with a specific quantum circuits. This is has been known a long time ago how to do, but we have done it at scale. So we did like largest single machine simulation. We did 41 qubits on an 18 terabyte machine that our partner AWS Bracket team has provided. And then after training the data on GPUs of various parts of distribution, we did full application and then had final distribution loaded into quantum state. And then the last step of the problem was to actually compute relevant quantity, which is valued risk, which measures the maximal loss that will occur with a 95%, like 5% VAR, means 95% confidence what is the largest amount of the risk the firm could incur. And then in this kind of scenarios, like classical methods are like typically classical Markov chain Monte Carlo techniques, where you take a lot of samples from existing data and try to estimate with a certain accuracy that's acceptable for this practical problem. With a quantum, you have this advantage that you kind of have the entire quantum state loaded in a real quantum computer. That's what it would look like. In a simulators, you actually have the full distribution, so it's slightly different settings. So it's not really a problem that could currently offer quantum advantage in the current devices, but it is a toy model that illustrates how powerful quantum can be in doing operations on distributions. And a couple numbers here in terms of benchmarks. To do this classically for the same accuracy, you'll need 64 million samples and 16 million operations. But in a quantum simulation, to get same level of accuracy, you need 41 qubits and 1,000 gates roughly to do that. Yeah, we are close to the end. So to summarize, BlueQubit focuses on building high-performance quantum simulations, leveraging GPUs, CPUs, Google's and NVIDIA's amazing tools. Current platform we have is 10x cheaper than other things you can use, so we would love researchers and quantum ML specifically, as the computational heaviness there is much more prominent. And yeah, we utilize best tools, tensor networks and QML training data we have in-house available. So for one ongoing project, we're going to use them. Not yet integrated in the platform, but will coming soon in next couple months. yeah, and this case study was an illustration how certain industries, like financial industries, can benefit for quantum and how to get ready for it.